In this video what we're going to do is have a look at calculations involving volumes of gases. So masses of solids and then volumes of gases. So our first challenge is to go back to our knowledge from the Introduction to Chemistry unit and see if we can write a reaction between a carbonate and an acid. So pause the video and see if you can write the reaction between magnesium carbonate and nitric acid. So there we go. Acid plus carbonate makes salt plus water plus carbon dioxide. The salts of nitric acid are called nitrates. The nitrate ion is a 1- ion, so the magnesium ion is 2+. We're going to need 2 nitrates for every magnesium, and I've balanced my equation. We're then being told some information. We've got 1 gram of magnesium carbonate. Now here's the magnesium carbonate, and it's reacted with an excess of nitric acid, so more nitric acid than we need. And it's asking us to calculate the moles from a mass of a solid. So go back to your knowledge of calculating moles from masses and see if you can calculate the moles of magnesium carbonate. So I've added up the MR of magnesium carbonate using my periodic table, and I've worked out the moles using mass divided by MR. Now it says state the moles of carbon dioxide, just state, hence state. That means it must be relatively straightforward to do. I don't need to calculate anything. And if we look up at the equation, the ratio between magnesium carbonate, the thing I've got, and carbon dioxide, the thing I want, they've each got 1 mole in the balanced equation, and therefore it's the same number. So that is the moles of carbon dioxide. So if it's reacting at 25 degrees C, 100 kilopascals, so I've been given a temperature and a pressure, I've got a moles, I've got the gas constant, I'm being given clues here that I need to be using PV equals nRT, and it wants us to work out a volume. So pause the video and rearrange that for V. There we are. Remember now to think really carefully about the units for PV equals nRT and convert everybody into the correct units. See if you can calculate the volume produced. So there we go. I had to convert my temperature into Kelvin by adding 273 and my pressure into pascals by multiplying by 1000, and that's going to give me the volume in meters cubed. If I wanted to have it, not that it asks me to convert it, if I wanted it in centimeters cubed, this would be the same as 295 centimeters cubed, because to convert meters to centimeters cubed, you times by 1,000,000. Why don't you pause the video and have a go at the next question. So if you've balanced your equation correctly, 2 lithiums need 2 waters to make 2 lithium hydroxides and a hydrogen. So it's 2 to 2 to 2 to 1. Remembering that lithium is a solid, water is a liquid, hydroxides are aqueous, and hydrogen is a gas. We're being given a temperature, a pressure, a volume, and we've got to work out the mass of the piece of lithium. Now, given that we've been given a temperature, a pressure, and a volume, we know we're going to be using PV equals nRT, but we're being asked to calculate a mass, and nowhere in PV equals nRT is there a mass. But there is a number of moles, and we can turn moles into mass, so let's rearrange for moles. So we've rearranged for moles. Let's substitute in the numbers, remembering all our conversions. So we've had to convert the pressure into pascals, and that's here, that was into pascals. We've had to convert the volume into meters cubed. Sorry, that's the wrong colour. The volume into meters cubed. So that's converting centimeters cubed into meters cubed, and the temperature into Kelvin. And type that on your calculator using the fraction button and see if you can get the number of moles. Now that I've got the number of moles, I can do mass is Mr. Moles. I can look up lithium in the periodic table. Lithium has a mass of just 6.9 even, but I can't go straight from there, can I? That's something we need to think about. This is the number of moles of hydrogen gas, because this was how much hydrogen was collected, I need to calculate the number of moles of lithium in order to be able to do the mass of lithium. So what's the number of moles of lithium? I'm going to need to use the ratio, and for every lithium to hydrogen, there was 2 lithiums for every hydrogen, so we're going to do 2 times 0.0177 to get the moles of lithium. 0.0354, and then the mass of lithium will be the AR of lithium, 6.9, times by the moles, and you're going to get that as 0.244 grams. So you're getting 440 centimetres cubed of hydrogen from such a small amount of lithium, a lot of gas.